Hi friends, here is a very interesting problem. We have to prove n power 5 minus n is always divisible by 5. It is already given. In some cases, there might be a rewording of this problem. We might be given some options, whether it is divisible by 4, 6, 8, whatever, like this. So let's see how we can prove this. So if a number has to be divisible by 5, what does that mean? That number should either end in 0 or in 5. Then it is divisible by 5, right? So hence n power 5 minus n, we can write it as n times n power 4 minus 1, right? Which we can write it as n times n square minus 1 and n square plus 1, right? This is a square minus b square, where a is n square, right? A square minus b square is a square plus b square into a square minus b square. This again we can write it as n times n minus 1 and n plus 1 times n square plus 1. Right, this is the expansion. Now let it be like this. Now let's assume this n, whatever is the n, right? This n can end in the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, this is the final digits. Final digit of any number. Final digit. We have only these options, right? Final digit can be anything. Right. Now, if n ends in 0, right, what will be the final digit of n power 5 minus n? Please notice n power 5 minus n has got one n, right, and remaining whatever it is, let it be. So that means 0 into, so n is ending in 0. That means in this term, this n is ending in 0, rest of it doesn't matter. So all of this will end in 0, right? Because n is ending 0, n can be 20, 30, 40, whatever, right? So all of this will end in 0. So this thing is when n is ending in 0. So n power 5 minus n will also end in 0. So 0 is sorted. We are not worried about 0. Right. When n is ending in 1, if n is ending in 1, in this term, n minus 1 will always end in 0. Right. If n minus 1 is ending in 0, forget about others. N minus 1 will be some 20, 30, 40, whatever. Then the product of 1, 0, one number ending in 0 and remaining whatever, that will all end in 0. So 1 is also sorted. N power 5 minus n. So in this, there will be 1 0 at least, right? N minus 1 is a 0 and remaining it doesn't matter. So the product will end in 0. Right. When it is 2, right? When it is 2, forget about, let's hold for 2 for now. When it is 3, 3 also, let's hold. When it is 4, when it is 4, then 4 plus 1 will always end in 5, right? N plus 1, 4 plus 1 will always end in 5, right? N plus 1 will be a number which n plus 1 will be a number which will end in 5, right? N plus 1 will be a number which will end in 5. And the product of this 5 and remaining all whatever. There is one 5, there is one number which is ending in 5. Let's say 25, 35, 45, whatever it is. Now, remaining all of this, whatever it is, remaining if it is odd number, then this entire number will end in 5. Remaining if it is even number, this entire number will end in 0. So, we are sorted for 4 also. Because if n is 4, n plus 1 will end in 5. If n is a number ending in 4, n plus 5 will end is a number that will end in 5. So, the product of all of this will be ending in either 5 or 0, depending on the remaining ones. So, the remaining ones, the multiplication of remaining ones is odd, then this number will end in 5 or otherwise it will end in 0. Right. Now n is 5. Right. If n is 5, obviously n is a number which is ending in 5. Right. Then depending again on the remaining numbers, because one number is already ending in 5, depending on the remaining numbers, which is n minus 1, n plus 1, and n square minus n square plus 1. If they are odd, this this n power 5 minus n will end in 5, otherwise it will end in 0, but nevertheless it will always be 5 or 0. So, so n ending in 5 is also sorted. Then also it will be divisible by 5. Similarly, n is ending in 6, then 6 minus 1 will always end in 5, right? N minus 1 is a number which will always end in 5. So the product will always be either 5 or 0. So this is also sorted. Right. We are left with 2, 3, 7, 8, 9. Right. Similarly, and 9 also. When 9 is there, n is ending in 9, n plus 1 will end in 0. Right. And the product of all of it will end in 0. So 9 is also sorted. We are left with 2, 3, 7, 8. Right. If n is a number which is ending in 2, right, n is a number which is ending in 2, then n square plus 1 will always end in 5. Right. N square is 2 power 2 n square plus 1. Right. For example, n is 12. Right. 12 square 144 plus 1. Right. N is 2. 2 square plus 1. Right. So n square plus 1, because n is a final digit. Right. Final digit square plus 1 will always end in 5. So it doesn't matter, remaining whatever. Then the product will either be ending in 0 or in 5. Right. Similarly, if n is ending in 3, then n square plus 1. For example, 13 square, 169. Right, n square plus 1, 170. Right, or 3 square, 9 plus 1. Right, so it will always end in, again 3 square, 9 plus 1 will always end in 0. Right, and number ending in 3, whose square plus 1 will always end in 0. So remember the product of all it will be ending in 0. So 3 is also sorted. Similarly, 7, a number ending in 7, when you do square of that, it will end in 9. 7 square is 49, right? It will end in 9 plus 1, which will end in 0. So this is also sorted. Similarly, 8. When a number is ending in 8, its square will end in 4. So its square plus 1, right, will always end in 5. So the product of all of it can be either 0, ending in 0, or in 5. So 8 is also sorted. What does that mean? And whatever is the number, it will always either end in 0, 1, 2, 3, 5, 4, 5, whatever. Any of this 9, 10 digits only. Right. And we have just proved whichever is the digit that is ending. Right. N power 5 minus n will always either end in 0 or in 5. That's how we have factorized this. Right, guys? This is a nice, very nice result, very important result. This question can be given in multiple formats. That's why it is important for us to understand the proof. Right. We earlier also we discussed something related, which is n cube minus 1, which is n into n square minus 1, which is n into n minus 1 times n plus 1. Earlier we discussed about this. This number, n cube minus 1, 3 is always divisible by 3. Why? Because it will create three consecutive numbers. N minus 1 and n plus 1 are three consecutive numbers. For example, it will create either 24, 25, 26, whatever is this, whatever is n. If n is 25, then we'll have 24 and 26. If n is 33, we'll have 32 and 34, whatever. Right. So in any three consecutive numbers, there will always be one multiple of 3. Because 3, 6, 7, 8, 9, a multiple of 3 repeats every third digit. Right. Every third digit, 3, 6, 9, every third digit is a multiple of 3. So any three consecutive numbers if you take, there will always be a multiple of 3. Right. So that's why n cube minus n is always divisible by 3. Earlier we have proved this result. This is a similar result. So the question can be given in multiple ways. It is important to understand the proof. Right, guys? Hope you like this. Thank you.